talk about some graphing, because that's going to be a big part of this unit. And the fancy name we give to it is something called coordinate geometry. You guys should be familiar, and I'm going to do this pretty quickly, how to plot points on a coordinate grid, okay? And how to read points on a coordinate grid. So just as a bit of a refresher, we use a coordinate grid to mark locations. And locations, I mean, that has tons of applications. I mean, anything that has to do with mapping involves this. And there's also, I mean, you could be mapping oil fields, you could be doing a map of the world, all sorts of things. And we can do things with these coordinate grids that we're going to see in this unit. So just to start with, the whole thing's called a coordinate grid. What we do is we take two lines, a horizontal, which we call X, a vertical, which we call Y, to split it into 4 quadrants, okay? And we start naming this one quadrant 1, and then we go counterclockwise 2, 3, 4. And the point where the two axes, that's what they're called, meet, is called the origin. And that's our reference point. That's what we always use, okay? And it is represented by the coordinate 0, 0. And so then what we do is to find locations on a coordinate grid. We always count how far we are horizontally from the origin, and then how far we are vertically. So like if I said, what's this point here? We would say, okay, in relation to the origin, we're 2 to the right, so that means positive 2. And then we're 3 up, so that means positive 3. If we go left or down, that means it's negative. So if I did something like this, that means starting from here, I go left 3, and left is always negative, think of a number line, and then I go down 3. So that's the coordinate of that point. Again, this should be reviewed. So knowing that, see if you can plot these 6 points. And instead of labeling with the numbers, just call them capital letters and label them with capital letters. So hopefully this should be pretty straightforward. Start at the origin and do your horizontal and vertical count. For example, if I wanted to plot 2, 3, start here. 2 means go 2 to the right. 3 means go 3 up. There's point A. Etc. Can I get a volunteer to show us where B is? And C? Yeah, after she's done. Good. Just label it B, capital B. All right, Zara. Pass it off to her. G? Yeah, good. E? Come on. Chat G. Don't be shy. and F. Good. Good, looks like we got a good handle on this. Great, thank you. Okay. Good. Now what about if we're asked to go backwards? You're given the point, you're asked to write the coordinate. So we can just write these beside the capital letters. Can somebody tell me the coordinate of A? Sarah?
Oh, 2 and 2.
2, 2?
4. Oh, 2, 4.
2, 4?
Oh, 4, 2. What?
Just shouting out random numbers or? B.
-2,
Negative 2, 5 is correct. C. Negative 3 is correct. D.
-1.
D. That was E, you got it. You're right. E is 0, -1. 4, -3. And F.
5, 0.
5, 0. Good. Okay. So we should be pretty comfortable with that. And the last little blurb that I put on here was, remember in quadrant 1, all the coordinates are positive numbers. Here, all the first numbers are negative, the second are positive. Here, all the numbers are negative in the first and the second. Here, the first is positive, the second is negative. Okay. So let's talk about some things. Let's talk about some things we can do using a coordinate grid. And we're going to talk about 3 things in the next 3 lessons. How we can use it to find distances, we can use it to find midpoints, and we can use it to find slopes. Okay, have you guys taken slopes and sines? Yeah, okay, good. For distance, the length from one endpoint on the line segment to another. So like I said, we can use a coordinate grid. Sometimes it's pretty easy. All we have to do is count. Sometimes it's not so easy, where we have to do something else. So like if I asked you to find, like if I said, okay, every grid line was 1 unit. What's the length of AB? 5. Because you just get it by count. Okay. If it's a horizontal line segment, we get it by counting again. What's the length of CB? 7. So that's pretty straightforward. But what if it's a slanted length or a slanted line segment? Now we can't really count because you can't say that's 1 and that's 2 because these are all different. So we need to come up with something else. What? Oh, wow. My apologies. Val, any ideas? Olivia? You know the formula? Okay, then I don't want it yet. Because clearly you're ahead. Any ideas? Slope won't help you with the distance. It'll be different. Yes. But we need some other type of math.
Find 2 points.
Find 2 points. Like find the coordinates of these points.
Find 1.
Okay. One. And this one is what, 4, 5? And then do what?
Find 3.
Find a formula. You're right, but how do we find it? Nicole? Yes. Make it into a right triangle. Because we can find this length by counting, this length by counting, and then we can do what kind of math? Yes, Pythagoras, a squared plus b squared equals c squared. So this length is 4, if we count it, 1, 2, 3, 4. This length is 3. So therefore, using a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse, well, one of the legs is 3, the other leg is 4. I don't know what the hypotenuse is. I'm going to call it EF squared. What's 3 squared and 4 squared? 25 is equal to EF squared. And how am I going to find EF?
Square root.
Square root 25,
Which becomes 5.
which becomes 5. But that's not very efficient. Because if you were asked to find, like, let's say you were just given these coordinates and said, ask, like, you know, this is the location of one town, this is the location of another town. What's the distance between those 2 towns? Do you really want to have to draw a coordinate grid all the time and then make a right triangle and then do Pythagoras? No, mathematicians are lazy. They want a formula. Okay? And here's what this formula looks like. I don't know why I keep drawing these things. Drives me nuts. If you notice, the distance from the first x to the second x is 3, or 4 minus 1. The distance from the first y to the second y is 4, or 5 minus 1. So I can find these lengths by doing second x minus first x, second y minus first y. That's how I can find these lengths without using a coordinate grid. So I can take the second x coordinate, subtract the first. That gets me the horizontal length. Second y coordinate minus the first gets me the x coordinate. And now what did we do after that? We did Pythagoras, right? We had to square these and add them together. And that gave me the hypotenuse squared, right? So if that's squared, how do I find just the hypotenuse? I got to square root this whole thing. And that is the distance formula. You will always get this formula, okay? I'm more concerned about if you know how to use it rather than if you know how to memorize it. So to find little d distance between any 2 points, you use this formula where x1 comma y1 is one endpoint And x2, comma, y2 is the other endpoint. That's the formula, okay? All right, let's see how we can use these. Let's do a couple of examples. So yes, the inefficient way would be to plot these two on a coordinate grid, draw a right triangle out of it, do Pythagoras. That's a lot of work. But we've got the formula. So it doesn't matter which one you call x1, y1, and x2, y2. It doesn't matter. Okay? So I'm just going to call the first one x1, y1, second one x2, y2, and plug those numbers into my formula and calculate. So the distance is going to be second x0 minus first x3, and then I got to square those, plus second y negative 5 minus first y 1, and then I got to square those. Add those answers together and square root. All right. What is 0 subtract 3? Negative 3, and I have to square it. Plus negative 5 subtract 1, negative 6, and I have to square it. Notice I'm still using parentheses, because when you square the negatives, they become positive. What is negative 3 all squared? 9, plus negative 6 all squared, 36. And when I add those two together, I get the square root of 45. Yep.
You would also do what we went first.
Okay, hang on to that 1 second. Yeah, I'll get you to do it. Notice it says, don't write your answer as decimal. This, like Olivia just said, this is what we did in the first unit. This is where you have to find the highest perfect square and break it down. And what is the highest perfect square, Olivia? 9, which means the other number must be, because 9 times 5 is 45. So the simplified answer becomes 3 square root 5. Good. Okay, so that's using something from unit 1 to answer this question. However, sometimes you'll be asked to do decimal, in which you would pull out a calculator and do it. So we've got 3 vertices, which are corners of a triangle, that connect to form a triangle. We have to find the perimeter of it. How many distances do I have to find? 3, because it's a triangle. So I have to find the distance from P to Q. I have to find the distance from Q to R. And I have to find the distance, from P to R. So I've got to use the distance formula. I've got to put an equal sign. Distance QR. I got to use the distance formula 3 times. Remember, square root, second x minus first x squared plus second y minus first y squared. So let's look at the coordinates of P and Q. What's the second x? 2 minus the first x, which is -3. So that's going to become plus. Square. Plus, what's the second y in PQ? 6 minus 5. So what is 2 subtract -3? 5 squared plus 1 squared. We could probably do this all in one shot. 5 squared and 1 squared. 26. That's not a perfect square, but remember, round it to the nearest 1 decimal place. 5.1. So it's approximately 5.1. QR. Now we got to change our x1s and x1, y1, and x2, y2. So we got to use these 2 points. So I'll use this as the second ones. This is the first ones. So square root of second x, which is what? -4 is the second x, minus the first x. Remember, we're looking at these two, -2 squared, plus 14 minus 6 squared. And this gives us -6 all squared plus 8 all squared. Can we do this one in one shot? 36 plus 64, 100, which works out to exactly 10. We don't have to round this. And now finally, PR, so we're going to use these 2 points. So these ones are going to be my second x, second y, first x, first y. So remember, look at these points now. What's the second x? -4 subtract -3, which is actually going to change to a plus. Plus 14 minus, good, squared. So -4 subtract -3, this becomes plus. -1, and we got to square it, plus 9 squared. Yes, well, this is 1. This is 81. 82, which we're going to have to use a calculator. 9.1. Okay. Remember, we're asked to find the perimeter, so we got one more thing to do. How do I find the perimeter now that I know the 3 sides? Add them up. 5.1 plus 10 plus 9.1, 24.2. And there are no units, so we don't have to write units. We're done. Okay. So that's distance. And where do we use this? Like I said, mapping, huge. Okay. Okay. So